We're solving problem 11 from the AMC 12B from 2022. Let f of n equal negative 1 plus I root 3 over 2 to the power of n plus negative 1 minus I root 3 over 2 to the power of n, where I is the square root of negative 1. We want to find the value of f of 20. So, well, what we can notice here is that, well, this typically occurs in patterns or so because, well, this might be a pattern because, well, this I switches through, negative and positive. That's a pattern, imaginary and real parts, even though the sum is going to be bigger. We can't just plug 2022 into this equation and expect it to work. And since this is a lot to write out, let's use some variables. Let's set a is equal to negative 1 plus I root 3 over 2, and b equal to negative 1 minus I root 3 over 2. So basically f of n becomes a to the power of n plus b to the power of n. That's that, which is pretty simple now. Now, we notice that a plus b is negative 1, and the product of these two numbers, a times b, is equal to 1. This means that a and b are roots of the polynomial x squared plus x plus 1. So we have our respective formulas here. A squared plus a plus 1 equals 0. B squared plus b plus 1 is 0. And since we want to have a power of n and everything, this starting power has to be n. So if we multiply both sides of both these equations by n to the power of, well, something to the power of n minus 2, we can raise all these powers to a power of n. Since n minus 2 plus 2 is, that's just n, this is a to the power of n minus 1 plus a to the power of n minus 2 is 0. Similarly, we get that this is b to the power of n plus b to the power of n minus 1 plus b to the power of n minus 2 is 0. Summing both these formulas together, because so when we sum these two formulas together, we get a to the power of n plus b to the power of n plus a to the power of n minus 1 plus b to the power of n minus 1 plus a to the power of n minus 2 plus b to the power of n minus 2. Okay. It's all equal to 0. And basically, what this simplifies down to is, well, we have these three groups of a plus b. This first thing simplifies to f of n, and then this is plus f of n minus 1, and then you add f of n minus 2 equals 0. Therefore, we have just proved that f of n is equal to negative f of n minus 1 minus f of n minus 2. That's pretty big for us. Okay, so we have this. If we substitute n equals 1, 2, 3, 4, 5, and 6 into this equation, this big equation here, we will get that the outputs of f of n are going to be negative 1, negative 1, 2, negative 1, negative 1, 2, respectively. And these, so basically, how I wrote this is that it's basically whichever number the number is, like for instance this 2 here, this corresponds to 3 because both of them are the third number. we notice here that only multiples of 3 will yield values of 2, and others will yield values of -1. So, all we want to do is find if 2022 is divisible by 3, and, well, it is. This is, let's see here. This is going to be 674, I'm pretty sure. So it is divisible by 3. Therefore, our answer is simply going to be 2.